Hello, everybody. So I'm going to read you two books today. The first book we're going to read is called Forces Make Things Move. The second book we're going to read is called Motion, Push and Pull, Fast and Slow. And these are science books to go along with what we've been learning about energy and motion. All right, so I'm going to switch my screen. Hold on one second. All right, so here is the first book, Forces Make Things Move. Look at all the movement going on in this picture. We got some water falling and flowing. We got a ball going up in the air. We got somebody swinging. There's a boat floating. She's climbing a tree. The rock climbers. All kinds of motion going on. If you push a toy car, you can make it move across. Your push moves the car. Your push is a force. Forces get things moving. Forces also make things stop. When the toy car rolls across the floor and stops, a force stopped it. Forces also make things speed up or slow down. Any push or pull is a force. Forces can move things farther away or bring them closer. Some forces are very strong. Some are so weak you can't feel them at all. Nothing starts moving until it is pushed or pulled. If you don't push your toy car, it just sits there unless something else pushes it, like the wind or your cat or your big brother. The wind, your cat, and your big brother can all produce force. The force moves your car. Anytime your car is moving, a force made it start. The heavier an object is, the more force it takes to start it moving. If you want to run across the yard, your feet have to push on the ground to get you moving. If you and your big brother decide to have a race, his feet will have to push harder on the ground than yours. Why? Because he weighs more. It takes more force to make him move. Once you run, another force can stop you. Your feet push on the ground to make you stop. If you want to stop quickly, it takes more force than if you want to stop slowly. You'll have to push harder. It takes a lot of force to start heavy things moving. That's why your living room couch doesn't fly across the room when you bump into it. It's why a breeze can't blow your family's car off the driveway. Other things, like leaves and papers and hats, don't weigh very much. Even tiny forces can make them fly around. A little wind makes enough force to make them move. But if your big brother is lying on the living room couch, you're going to have to push pretty hard to force him off. Whenever you push something, it pushes back against you. If you push a toy car, it pushes back against you with the exact same force. If you push harder, the toy car pushes back harder. This can be difficult to understand, but it's true. The force you put on the car is always the same as the force the car puts on you. Excuse me. If you push the toy car, your force makes the car start moving. So if the toy car is also pushing you, why don't you start moving? Because you are so much heavier than a toy car. Remember, it takes more force to move heavy things. The force that can move a toy car can't move you. Since it takes such a small amount of force to move the toy car, and the toy car puts only that much force on you, the force is too small for you to feel. And she says, "Who pushes harder?" Like there's a speech bubble. What does that tell us? Someone's talking. If you push your family's real car parked in your driveway, it pushes back too. Just like your toy car, the real car pushes back with the same amount of force as you put on it. If you push the real car gently, it pushes back gently. If you push harder, you can feel it push back harder. Your force is against the car, and the force from a car is against her. And he's laughing. Ha ha ha. You can't produce enough force to move the real car. Neither can your big brother. Sometimes you can see what is pushing or pulling, and sometimes you can't. If you roll your toy car and it hits a wall or the couch, you can see that the wall or the couch stops the car. The wall and the couch produce force. If the car hits your big brother, you better run. If the car doesn't hit a wall or your big brother, or the couch, or the cat, or anything you can see, it still stops. What is pushing on the car to make it stop? A force called friction. Everything is bumpy, even things that feel smooth, like glass or ice, is still a little bit bumpy. You can't feel the bumps of glass, they are too small, and you can't see them either, but they are still there. Whenever two things rub against each other, the bumps on those things rub against each other. The force of the bumps rubbing against each other is called friction. Friction makes moving things slow down. When you roll your car, the bumps on the floor push against the bumps on the car's wheels a little bit. This friction is the force that stops the car. If you push the car along a shiny wooden hallway, it rolls much farther than if you pushed it along a thick bedroom rug. The rug is bumpier than the hallway. It creates more friction. It makes the car stop more quickly. And he says, "Wow, look at mine go." And he's saying, "Mine doesn't roll." What if you roll your car across very slippery ice? It will go even farther than it does on the shiny wooden floor. The ice is so smooth that the force of friction is very small. But even if the car isn't touching anything, even if you pretend it's an airplane and throw it right through the air, it still stops moving. It falls to the ground. Two forces stop it. One is friction. Even air has a small amount of friction. In space, there is no air. So in space, there is no friction. If you were an astronaut and you threw your toy car into space, no friction would slow it down. Your car would keep going forever unless it ran into your rocket ship. The second force that stops the car is called gravity. If you drop the car, it falls. Why? Why doesn't it stay up? You haven't thrown it down. You haven't pushed it or pulled it, but it moved. So some other force must be pulling it down. That force is called gravity. Gravity is the force that every object has for every other object. Gravity at work, the cat's thinking. You have gravity. Your big brother has gravity. If the two of you are standing on opposite sides of the room, you both have tiny tiny amount of gravity pulling you toward each other. You will never feel the force from this gravity. It is much too small. Can you feel my gravity? No. The gravity force between any two objects depends on how much they weigh. Most of the time, gravity is a teeny tiny force. When you hold a carrot in your hand, there is a gravity force between you and the carrot, but you'll never feel it. There is a gravity force between your big brother and your cat, but neither of them cares. You can feel the gravity between you and another object only if either you or the other object is really, really huge. Like really huge, like the size of the entire Earth. The whole planet. Everyone can feel the Earth's gravity. It's a big force. The Earth's gravity pulls you and everything else on or near the Earth down. It pulls things toward the center of the Earth. If you dug a deep hole and dropped your big brother into it, he'd fall until he hit the bottom. The Earth's gravity would pull him all the way down. The Earth has so much gravity that when we say gravity, we're almost always talking about the Earth's gravity, not the gravity between you and your big brother, or the gravity between a carrot and a cat. Gravity is such a part of our everyday lives that you probably don't even think about it. If you spill a glass of milk, you expect it to spill down onto the floor rather than up onto the ceiling. If you let go of your toy car, you can expect it to fall to the ground. If you throw your car across the room, you expect it to end up on the floor, not suspended halfway up the living room wall. Gravity is why apples on trees fall down to the ground instead of staying up in the sky. Gravity makes it hard to throw a baseball all the way to the moon. It's why your parents' cars stay on the ground instead of soaring through the air. It's why rockets to space have such huge engines. The big engines make enough force to be stronger than the gravity. Forces are all around us. Forces make things go faster and slower. They make things stop. They make things start. Forces get things moving. Come on, Sparky. Okay, so that was the story, Forces Make Things Move. And then our second story is Motion, Push and Pull, Fast and Slow. Ooh, there's a table of contents. What does that tell us? Let's see if there's a glossary. There is, right here, a glossary. And there's some experiments that you could do. And there's the index. So this tells me it's going to be a non-fiction informational text. Changing places. You run to catch the bus, the school bus. The bus rolls down the road. Tree branches sway in the breeze. An airplane flies up into the sky. Anything that goes from one place to another is in motion. Fun fact. There are all kinds of words to describe motion. You can run, walk, jump, dance, swim, slide, and skate. Birds soar. Snakes slither. Monkeys swing from tree to tree. What other motion words can you think of? How things move. Up and down, forward and backward. Some things move in straight lines. Sideways or around and around. Some things move in curved lines. Fun fact, One car travels over a hilly road. Another car travels a winding road. Both cars are moving in curved lines. A car whizzes down the road. A baseball crashes through a window. Some things move quickly. A baby crawls across a room. A ball of yarn unwinds and rolls away. Some things move slowly. Fun fact: how fast something moves is called its speed. You can measure speed. When the needle on the car speedometer points to 60, it means that it will take 1 hour for the car to move 60 miles, or 97 kilometers. Let's get going. A kick from your foot makes the ball scoot across the field. Stepping on the gas pedal makes the car drive away. Inertia is a property of all matter. Inertia won't let things move unless a force gets them going. A kick is the force that moves the ball. A motor creates the force that moves a car. Fun fact: pushing down on the car's gas pedal adds force. It makes the car go faster and faster. Going faster and faster is called acceleration. Your bag slips off your shoulder. What is the force that got it going? What makes yo-yos dip and water spill? Why do baseballs curve down? The Earth's gravity is the force that pulls everything down toward the ground. Fun fact: things speed up as they fall. A raindrop that is close to the ground is falling faster than a raindrop high up in the sky. A rolling ball, a speeding car, and a falling raindrop will keep things moving until something stops them. Inertia also makes moving things keep on moving. You need to wear a seatbelt because of inertia. Suppose your car stops suddenly. Your body will keep moving forward until a force stops it. A seatbelt stops your body and keeps you safe. Fun fact: inertia also keeps things moving in one direction. It takes an outside force to turn or spin something. Your bike won't turn unless you move the handlebars. Kites won't dip without wind. A baseball won't curve downward without gravity. The ball you kicked rolls across the grass. As the grass rubs against it, the ball slows down and stops. This rubbing is called friction. Friction is a force that makes things slow down or stop moving. Anything that rubs can cause friction, even air. People who design airplanes think a lot about how to keep air from slowing things down. Fun fact: you need friction to walk from one place to another. Your shoes rub against the ground. This makes friction that keeps you from sliding all over the place. Who's moving? You are on a moving bus. Some friends outside see you looking out the window and wave. Your friends outside think you are moving fast. But what about the friend next to you? Does this friend think that you are moving fast? Not at all. Fun fact: think about driving down the highway. The cars in the other lanes don't seem to be moving fast when your car is moving alongside them. The world is full of motion you can't see. Even as you read this book, you are speeding through space. You are on the earth, and the earth is spinning around and circling the sun. Leaves are fluttering, raindrops are falling, cars are whizzing by. Look for motion and the forces that create it in everything around you. Fun fact, it looks like the sun moves across the sky, but that is not the case at all. The earth is moving. As the part of the earth that you are on turns toward the sun, it becomes day. As the same part of the earth turns away, it becomes night. Okay, and then here's the glossary. We have the word acceleration, which means speeding up. Force, anything that can cause a change in motion. Friction, the rubbing of one surface against another. Friction stops or slows down moving things. Gravity is the force that pulls objects toward the Earth's surface. Inertia, a property of matter that makes things resist changes in motion. And speed, how fast something is moving. Okay, so I hope you enjoyed those two books, and I hope you were listening, because you have a new assignment today for science. You are going to work on a word search, force and motion word search. And here's the words down here that I want you to find. And do you see the colors? That means you are going to find those words and highlight them in the color. So the first word is direction. So I need to find direction. Oh, here it is. And I'm going to put it in blue because that's what it says to do. Direction is in blue. Okay. And then pull is in brown, gravity in red, motion in pink, resistance in yellow, friction in purple, push in orange, and magnetism in green. Excuse me. And then on here, you're going to look at the picture and decide, what is it doing? What is he doing? Is that a push? So you would write push. Is it showing gravity? Is it showing a kick? Okay, and then you're going to color the picture. All right. Okay, and so that is the end of this lesson. Bye, guys.